Okay. All right. So next up, we're going to have Melissa Warren is going to be talking to us about Kworkflow.
Hi. Okay. Yeah, good. So, hi, I'm Melissa. I am a kernel GPU driver developer at Igalia. And today I will give a talk, a very inclusive talk, to not let your motivation go, by saving time with Kworkflow. So you are a kernel developer, or you want to be a kernel developer, or don't want to be a kernel developer. But at some point, you are united by a single need, that you need to validate a custom kernel, just one change. But yeah, you need to check if it fixed something or it's actually improving something. And then it's a given change for a given distribution, or for a given device, or for a given subsystem. Oops. Maybe you can try to figure out the number of subsystems that we can have, and the number of threads that we can have in the kernel. So being or not being a kernel developer, at some point you could face this kind of situation. That is, for example, a user space developer just want to report an issue in the kernel, and then they say, oh, there is an issue in your driver, and it's only reproducible when you are running this distribution, a specific one. And then the kernel developer just asked, oh, did you check the last version of this branch to see if the issue is still there? And the reporter never compile and install a custom kernel before, so they needed to read many kernel tutorials and documentation to create and build a build and deploy kernel script. Then finally, the reporter managed to check if the latest version of this branch is better or not, and then they just say, sorry for delaying. It's my first time deploying a custom kernel, and I am not sure if I did it right. So we have this variable. But the issue is still present in this kernel branch. We can say like this work branch. And then the kernel developer cannot see this issue in the target device that they have. So, okay, I need now to reproduce this issue in my side, but I never used this distribution because we have many distributions. So they also created almost the same script created by the reporter. The problem, you keep creating new scripts. Every time you change distribution, architecture, hardware, or even a project, even inside your company, you just change to another project and you need a different workflow. So you create another script to your new kernel development workflow. And you know you have many babies, you have a collection of my precious script. So instead of creating and accumulating scripts, save your time with Kworkflow. That is more or less an example of typical scripts that you can have, probably. Many of you have this kind of script. This is for Raspberry Pi 4. And then this everything that I need to, or to create a script or memorize, to just deploy, install and deploy a kernel in a target machine, so cross-compiling and things like that. And the Kworkflow, I just need to remember two commands. So what is Kworkflow? It's a collection of tools and software combined to optimize Linux kernel development workflow, reduce time spent on repetitive tasks, because we are spending our life compiling kernels, standardize also best practice, and ensures reliable data exchange across kernel workflow. Like you have your setup, but someone have a different one, and you are not seeing the same thing, even if you are describing the same setup. So Kworkflow also help on this. I don't know if you will get this analogy, but for me, Kworkflow is kind of a Power Ranger Megazord of scripts. So you are just combining all your scripts to create a very powerful tool. What is the key features of Kworkflow? We have many, but this I think the most important one. You can build and deploy custom kernel across devices and distributions, handle cross-compilation seamlessly, manage multiple architecture settings and target device in the same worktree, organize kernel configuration files. It facilitates remote debugging and code inspection. And it standardizes Linux kernel patch submissions guideline. Probably you already checked it on the documentation, or maybe Greg already complained that you are not following something when you just need this bug fix to stay stable. So, and then we also have an upcoming feature that is an interface where you can bookmark, apply, and review by patches from the mailing list from Lori. So this is a list of commands that we have. We can find Kworkflow. So the first subset is around to set up and configure your tool to all the different situations that you can face in your daily tasks. You have another subset that is to build and deploy custom kernel, as I mentioned. We have also some tools to manage and interact with target machines remotely or locally, and to inspect and debug a kernel, to automate best practice to patch submission, like code style, maintainers, but also send patch. We can ensure that you are sending patch to the list of recipient and mailing list for this change, that is who needs to know about that, and then the upcoming one that is the patch hub. So how you can save time with Kworkflow when you are building and deploy custom kernel. So first you need a config file, and probably you are like manually extracting and managing config files from different targets. Sometimes you are just renaming the config file with a bunch of different suffixes trying to describe, oh, this config file is to this setup or this machine. And copy-paste, of course, because, yeah, we loved it. And on Kworkflow, we can use just the kernel config manager command, and it will do, you can save, you can store different config files, describe it, and then you can get it back and apply on your kernel. Then you need to build the kernel, and probably you are memorize a combination of make commands and options. And you just need to run the Kworkflow B, the build from build. And then you can build a kernel with cross-compilation, C flags, C cache, LLVM. You can set up previously the CPU scaling factor. You can also check information about the number of modules that we have there. And you can enable compilation warnings and many other options. You also have, and then after get the config file, build the kernel, and then you need to deploy it. And then before you probably do some SSH, or you copy or remove files according to your distribution and architecture, and you manually update the kernel according to the bootloader of this distribution. And now you have the Kworkflow D that you can do all these things like deploy the kernel, prepare a target machine before to receive this kernel. You can list the available kernel, custom kernel, or already from the distributions that is already installed there. Remove kernels, create shareable package, troubles, and you can just put some settings like, oh, after deploy this kernel, I just need to reboot to check if the new custom kernel and everything that I need to check is okay. I don't need to SSH again and do this. And we have the abbreviation, the combination of Kworkflow, the build and deploy in one command. You can also save time debugging kernels locally or remotely. So previously SSH, manual setup, enable trace, and now you have the Kworkflow debug that you can use. You can use many debugging tools that we have in the kernel, like events, ftrace, and also the dmask, and you can handle this from your local machine to remote target or even your own. You can also manage multiple kernel images in the same work tree. We have the environment command, the environment feature that we just kind of, you can, before you were like having multiple cloning, multiple repos, you are cloning the same time multiple repositories because you need to separate, to isolate your compiled files by, for example, if you need to cross-compile or if it's x86. And then you have an environment that you isolate both the configurations, the setup of the target machine for this, but also all the options, the compilation options and deployment options for this specific kernel in the same work tree. So you just need to change the environment, and you can apply, for example, the same change for different setups and configurations. So, and also, finally, we have the feature to submit patches. We have the basic things. It's mostly a wrap from options that scripts that we already have in the kernel. But we have the send patch. That is, it will automatically create the list of recipients and send patch via mail. And also, it's kind of automatize the patch submissions rules when you need to send a patch using git send mail, and we have the documentation and it follows these rules there. So it's the last one is the upcoming one. It's a volunteer project, and it's a demonstration that the developer that is doing that is showing that you can you have an interface to deal with lore, and then you can bookmark patches, you can apply a patch or a patch series, and if you are satisfied with the result, you can review by, and it will send automatically revealed by for this series. Then a call to action is stop writing redundant scripts. Save everybody's time. It's not only your time, but everybody's time and effort with Kworkflow. Try with Kworkflow today and contribute to Kworkflow also, because it's a 100% volunteering work. Nobody's paying for that. We are like a bunch of developers with many scripts that we decided to share all of our scripts and try to standardize that. And so a challenge is replace one of your scripts with Kworkflow this week, or you can make a new Kworkflow feature with one of your scripts. I would prepare a demonstration, but many people just told me to not do that and live demonstration because I will get failed. So I decided to just record that. It's how we can use the Kworkflow environment. So this is a list of environments. I have my local machine that is an Intel one, and I have a Raspberry Pi 4 with the 64 Raspbian, and I have the Steam Deck. So this one, I am check my local machine, and I have the VKMS display driver. That's a virtual kernel driver, and a kernel multiset driver. And I decided to have a better description because I was previously a maintainer of this driver, and I would like to get my baby back to me. So I just put here as my precious VKMS. And I decided, okay, I already have all the files compiled, so it's just one change. So I just need to compile and deploy this change in my local machine. So I don't need to do everything again. I just need to run wbd, and it will build and deploy in my local machine. And then it will prepare everything and install in the kernel. And then you can see that I didn't mention about that before, but it was like I am using the same kernel. So I just replaced the module there. And then I have now, when I try to get info of the VKMS, now this is my precious VKMS. And I am satisfied. I don't need this anymore. And I just need to, but I want to use the same worktree, that is the main line. So I will now change for a different environment using the same worktree. And now I have ARM64, that is the Raspberry Pi 4, and I will use this environment right now. So what it means, I already have all the configuration of the target machine. You can check this is the device. It can show you the information of the device. The delay is because I was using my smartphone to have a connection network. So you can see it's the release, the kernel. We have the information. It's the kernel that came with the distribution, and you can have all the information about the device that I need to deal. And then what I want to do, I will just deploy the kernel, because I have all the files already compiled and it was isolated. Even if I am using the same worktree and I just change the environment, it will just install that. And then I just set that because I would like to be a bit fast when I reboot, and I don't need to check anything about the graphical interface. So I ask it when I reboot, after deploy and reboot, I will not have this graphical interface enabled. And I just pass kw deploy and reboot, the option reboot. So what it will do, it will automatically deploy and reboot my machine. So it's sending the patch. It's a remote machine. It's not mine anymore. It's not the local one. So it will take some time, and let's see. Yeah, sometimes it's not that. That's why I recorded. So basically, it will also, I am using the upstream kernel, and Raspberry Pi has a downstream version that is more stable, but it's work. So you will see some warnings when it deploys, but it's working. It's more or less like that. So you probably will see many missing firmware, and also they will complain that they cannot find something. Let's see if it can run a bit more. And that's it. So what it say that this error, you can just ignore it. It will work. But then they close the connection. What it means, I deploy the kernel and I already reboot the machine. And then I try to access via SSH that I have wrapped in my Kworkflow, and it's try to access and it's not reachable because it's restarting. So then I will try again when I see that it's actually completely load. And then I will see that now I have the mainline kernel installed. You can see in the first line of that. I just need to leave the machine. And then I will change again to another setup that is the Steam Deck. Currently, I am working with Steam Deck. So it's now I am back to the x86 setup. But what is the difference here? My laptop is an Intel one, and this one is an AMD device, AMD GPU, and I am using a different distribution. Here I have Debian one, and that is the SteamOS that's based in Arch. And then I already have the mainline kernel installed, but there is a difference. I tried to load the VKMS, and I think it was not that motivational as I was expecting. So I just changed it. One thing that when the loading of the module is completed, I want something like that keep motivating me to contribute to the kernel and to do my change. So I just put this kind of message that doesn't do anything, but it's a print K like that we love it, I know, when we are debugging things. And basically it's just to say, let's go, keep doing, no meaning. It's many motivational stuff just like that. And then I can deploy the same thing. I will just build and deploy the kernel. Now it's a remote machine too, even it's x86, it's a different distribution also. And what I will have, okay. I am in time, I think so. It's just a bit of delay, but it will happen. Yeah. Sending a module. Because it's prepare patch, it's sending remotely. You need some time, everything's done, it's transferred. And then, what do we have here? When we deploy, we have some issues with client CPIO, but we can ignore it because we know it will not affect the kernel. And now I have the let's go VKMS here, and I am motivated to keep contribute to the kernel. So basically it's that. And thanks, I don't have anything more.
Questions? Oh, all the way at the top, the first one. Yay.
Hi. Thank you first for creating this. I'm a kernel maintainer myself, and this looks really very promising to reduce my workload. And the first question I have is this also possible? Does this also allow like importing patches from Patchwork and then just like basically putting them into your tool and it will like go through the process itself and test it? And the second question is, can you also use this to automate bisecting? Thank you.
Okay, for the Patchwork interaction. We don't have it already. We only interact with the lore right now, and it's under development. It's a volunteer work, so it's not that fast as expected, and we are also we need contributions. But you can, for example, open an issue requesting this improvement, and when we have time, our spare time, instead of sleep, we decided to improve the tool. And about bisection, we don't have yet the same. So it's a good idea, and I think if you can open an issue, or if you can contribute, better. Or if you already have a script for that, we can incorporate. We can incorporate in the tool in a standardized way.
Just a minor follow-up. I mean, it doesn't necessarily have to be Patchwork, but so currently when someone sends me a patch, I just look up the message ID and I just fetch it with B4.
Yeah,
So
yeah.
does something like this already work?
The Patch Hub, this upcoming feature, it's used before. So we have like a fancy interface, but it's actually used before to, you can select the, you are not subscribed to this mailing list, you can just access this mailing list and select the patch that you want, and you can just check that you want to apply this patch, and it will be applied. And also, when you are satisfied, you tested, or you didn't get anything wrong, you can just say, okay, I accept that, I reviewed that, and we will send your reviewed by automatically. So it's automated already. It's under development, so it's an unstable version right now, but we are trying to finish this, complete that.
I have a question. Do it support kexec? So you can switch the kernel without rebooting the machine, so be faster into testing a new feature?
For module, yeah, we can do that. But if it's a built-in thing, we need to reboot. I mean, that's the way that we have.
Thank you.
If the module works properly when you load and unload, because sometimes you try to unload the module, it is completely broken.
So 2 questions. First one, is there any support for Android, like using ADB instead of SSH? And the second question, kind of related to distros that cannot have multiple kernels. Is there any safety net in case the kernel that you just flashed is completely broken, the target is not going to boot again?
Okay. Yeah. Not as, I mean, you can reboot if you have a bootloader that you update group and it's managed correctly. You can deal with that.
If you have group, but if you have, for example, U-boot, right, and you have only one kernel in boot image, and then you flash it, and that basically means that you will end up in U-boot that is in fastboot or something else. So is it possible for the tool to support flashing over USB instead of just going to the target and deploying through some distro mechanism?
Not yet, but it's a good feature.
Anything else?
Just one question about the patch submission. Does it wrap around before like completely or partially, or is it work in progress?
It's we already we used before already. I mean, many of our commands we are reusing before features, but it's under development yet. It's not completed.
Hi, thanks for the talk. A tiny question. Because I see that there are some systemd bindings, I wonder if there is support for other stuff such as Runit or OpenRC.
If there is other, no, it's not yet. Yeah.
All right, I think we'll wrap it up there. Thanks a lot.
I don't know if it's connected yet. The last thing is, I see you have many ideas. Probably you have many scripts. So if you already have it in your machine, maybe you should consider to just, submit a proposal to us with your script, and it will make our life easier. So basically that.